So what if I told you that the key to building smarter, more resilient AI wasn't hiding in some high-tech lab, but was actually found in the structural patterns of an ancient text? It sounds kind of wild, right? Well, today we're going to unpack a totally new way of thinking about our most complex technology. It's a journey that starts with plain old curiosity and ends with a design principle that could, just maybe, help our systems finally learn to evolve. Okay, let's get into it. And this whole story starts right here, with this simple admission. The person behind this idea didn't come from computer science or engineering. They weren't setting out to solve some big tech problem. Nope. What they had was a fascination with patterns and a nagging question about why things just seem to repeat themselves. It's a great reminder, Sometimes the biggest breakthroughs come from way outside the box. And this is the question that kicks everything off. I mean, think about it. In our lives, at work, and especially with technology, we see the same old problems showing up over and over again. We patch them, we put a Band-Aid on them, but they never really go away for good. This isn't just annoying, it's a signal. The system is trying to tell us something important if we just stop and listen.
So if you're trying to solve a problem in modern tech, where do you even start looking for answers? Well, in this case, the search began somewhere completely different. Not by looking at lines of code, but by looking at the deep, almost mathematical structure of an ancient text, treating it less like scripture and more like a massive data set.
Yeah, you heard that right. This was not a theological study. The Quran was basically treated like a giant database. The goal was to analyze its structure, things like how often letters appear, word repetition, the density of information, just to see if any deep, hidden patterns would emerge from the text itself.
And you know what? A really clear pattern jumped out. It was almost like a rhythm. You can see it here. The shorter chapters or surahs had this high density of repetition. Core ideas were hammered home again and again. But then the longer surahs showed way more variation, a much more even spread of new concepts. This wasn't random at all. It was a consistent rhythm baked right into the structure of the book.
This observation led to these two really powerful concepts. First, you have compression. That's the state of high repetition, low variation. Like it's really focusing on a single, proven idea to make sure it sticks. And then you have expansion, which is the exact opposite. Tons of variation, exploring new ideas, introducing new possibilities. The text wasn't just doing one or the other, it was naturally alternating between them. Okay, so this is where it all clicks. Armed with this idea of a natural rhythm between expansion and compression, the focus snaps right back to technology. That same question from the beginning now has this powerful new lens. Why do our modern, super sophisticated systems get stuck in these dumb, repetitive, inefficient loops? It's because they get stuck in a state of permanent compression. Think about it. A server fails, so its only move is to try again on the exact same broken path. A data pipeline hits a bottleneck, so it just sits there, waiting in line behind the same blockage. The system is built to focus on one path, one solution, and just repeat it. Even when it's obviously not working, we fix the symptom, but that underlying pattern, it's still there. And this is the gut punch, really. Our systems are built to be incredibly fast, incredibly reactive. They can fail and retry in the blink of an eye, but they aren't actually learning anything from the failure. They're just repeating the same mistake, only faster. It's all brute force, no actual intelligence. So this slide really illustrates the breakthrough. The old way, the way we've always done it, is to constantly optimize for one thing: speed, efficiency, whatever. But what if that laser focus is actually the problem? What if a healthier, more resilient system needs an alternating rhythm, a balance between using what it knows works, that's compression, and exploring new ways to solve a problem, that's expansion? And that brings us to this new design principle, loop-aware thinking. The idea is so simple, but it changes everything. A repeated failure isn't just some random error log you can ignore. It's valuable information. It's the system screaming at you, hey, this path I'm on, it's a dead end. This isn't random, this is a loop. So here's how it would actually work. A loop-aware system first notices these repetitive, inefficient patterns. Then, instead of just trying the same thing again, it generates a totally new alternative way of doing the job. But here's the magic trick. It doesn't just switch blindly. It runs the original path and the new experimental path at the same time, in parallel, to see which one actually works better. It experiments, it measures, and then it learns. Okay, this might sound like a cool but subtle engineering tweak, but the implications are actually huge. Why should we really care if our systems are stuck in loops? What's the real cost here?
It matters because these loops are unbelievably expensive in ways we don't always see. Every single pointless retry wastes electricity, adding to a massive energy footprint. Every repeated failure burns up CPU cycles and costs real money. And honestly, it wastes the time and talent of engineers who have to keep putting out the same fires, day in and day out. It's like this massive, hidden tax on our entire digital infrastructure.
And look, this isn't just a niche problem. In AI, it's all the wasted energy from training models that get stuck. In the cloud, it's paying for extra resources to handle bottlenecks that we know are coming. And in really cutting-edge fields like quantum computing, where jobs fail constantly, it's a platform that records every failure but doesn't actually change its behavior.
Now, it's really important to be clear about what this idea is and what it isn't. This isn't being sold as some new law of physics or a grand theory of everything. It's much more down-to-earth and practical than that.
What it is a powerful new design principle. It's a practical, engineering-focused way to think about building our systems differently. It's a shift from just creating things that blindly follow instructions to creating things that can observe their own behavior, learn from their own mistakes, and actively evolve to get better over time.
And that kind of leaves us with this final, really fascinating question. For decades, we have been obsessed with making our systems faster, more reactive. But what if the next great leap forward isn't about raw speed at all, but about adaptation? What if our technology could finally break out of its repetitive loops and truly begin to evolve?